All right. I'm going to back this up just a little bit, and hopefully it doesn't stay fuzzy here. That's good enough. Okay. So, first thing we're going to do here with this stuff, guys, is we're going to just focus on reducing or simplifying rational expressions, because that's really the backbone of this whole thing. Is can we take a rational expression, something over something, and break it down, simplify it? Because then when we go to multiply, once we do the multiplication and the division, that's what we need to do. And that's really the most difficult part of this whole process. So let's just focus on that to begin with. So let's say we have something like x squared plus 5x plus 6 over x squared plus 6x plus 8. And we want to try and simplify that expression. Okay? So to simplify it, we want to break it down as much as we can, the numerator and the denominator, and then if there's anything there that will cancel out, we can go ahead and take care of those and get them out of there. And then whatever's left over is our simplified version of this. Okay? So I gave you a couple of trinomials here that I think are pretty easy to factor. Stop me if I'm wrong, but I felt like they were. So, and these don't have coefficients on x squared, so we can just play that game of what adds to the middle term but what multiplies to the last term and use that to factor them. And then let's check it out and see what we got. Okay? So, x squared plus 5x plus 6, what does that factor to? So that one's x plus 2 times x plus 3. And then what about x squared plus 6x plus 8? What two factors work for that? All right, so do you notice how, actually, can somebody shut that window blind right there? It keeps getting on me. This one right here, if you don't mind. The other one too, maybe, because it keeps jumping on this thing here. There's a little knob, you just turn it. Yep. Perfect. Thank you. All right. So do you guys notice how there's a common factor in the numerator and the denominator? So we can cancel both of those two out, and then whatever's left over, x plus 3 over x plus 4, that's the simplified answer then. Okay? That's the basic idea. Now, it's not always quite so cut and dry as that one, though. Okay, so we'll do a couple more of these, and then we'll get into the multiplying and the dividing that goes with it. So let's say we've got... Okay, let's try that one. So 3x squared minus 12x minus 36 over 6x squared minus 24. The process in general is still the same. You want to factor the top and factor the bottom and see what you have left over. Okay, so 3x squared minus 12x minus 36. That one has a GCF we can take out first. And remember, when you're factoring, you always want to look for that first. Is there something common to all the terms that we can go ahead and take out? So what goes into all three of those? 3, right? Okay, so let's do that first. So if we take a 3 out of the top, we've got x squared minus 4x minus 12. And then same thing with the denominator. Is there something that goes into both of those two terms I could pull out first? What can I take out there? A 6, okay. And that would leave us with x squared minus 4. Okay, but then I got to keep going though. Okay, so x squared minus 4x minus 12, that still factors. And x squared minus 4, that still factors too. Okay, so x squared minus 4x minus 12, anybody got that one for us? What does that factor to?
3 x plus 2 to x minus 2.
Oh, you did the bottom.
Oh, I did?
Yeah. You did x plus 2 and x minus 2?
Yeah.
Those two multiplied to negative 12?
X plus 2, x minus 6.
Oh, okay. All right. That was a close one. All right, so x plus 2 and x minus 6 for that one, yeah. And then the denominator, it's x squared minus 4. Do you guys all recognize that difference of squares there? Okay, so that would be x minus 2 and x plus 2 for that one. Okay, so again, what cancels? The x plus 2's cancel out. Yep. But there's something else too. The 3 and the 6 can be reduced, right? Anytime you end up with those constants pulled out like that, think of it just as one little fraction kind of floating in front. 3/6. Can you reduce 3/6? 1/2, right? So you can go ahead and reduce that too. So what I would do is just make this a 1, make this a 2, kind of like that. And then go ahead and multiply, rewrite what you have. So 1 times x minus 6 is just x minus 6 on the top there. And then 2 times x minus 2. So this would be this one simplified as far as it'll go. Okay? So you got to take a look at those constants too. If you pull out those GCFs, take a look at those and see if those can reduce as well. And if they can, go ahead and do that too, and then you're good. Okay? So that would be your final answer for that one. So, all right. Maybe let's do one more with the factoring. So we've got, all right. That's cubed. Yep. Sorry, I should probably zoom that in just a little bit.
Excuse the interruption. We have a few announcements. Welcome back, students. If you would like to attend a C-Club field trip on Tuesday, January 13th, there will be a bus transporting students to Bittersweet. Bus leaves at 3:45, returns at 10 p.m. The cost is $10 plus fees and rental. If you're interested, please sign up by January 9th. We must have 14 students on board before the trip can go. Seniors, if you haven't completed your diploma information, it's available in the office. Please do so as soon as possible. Lastly, congratulations to the following students who won the Nice Job drawing for the month of December. Nathan Millette, Megan Schultz, Sid Vandertine, Jake Claypool, and Mason Shandor. If you haven't yet received your prize, you may pick it up at the office. Thank you.
Okay. So, let's do some factoring again. This one's so easy it's hard, or so hard it's easy, I don't know. But, numerator. What's the GCF of the numerator? X, right? You can take an X out of that. Okay, don't forget about that. Now, if you take out an X, we got x squared minus 2. And then the denominator, well, we can't really factor 4x. It's just 4x. So, is there anything that's going to cancel there? The x's can cancel, right? Now, be careful. They don't cancel until they've been factored, though, okay? So don't try to start, like, canceling, with each one individually. Or, like, I've seen a lot of people, they'll take something like this, and then they'll just cancel the x's like that. And say, look, I canceled them right there. They canceled out. You can only cancel factors with factors, okay? And this is 4 times x. These are each little itty-bitty factors, right? The 4 and the x. So that's okay to cancel with the factor of x. But you can't do something like this. That's a big no-no. Because it has to be a factor up top. So now it's safe to cancel the x's. And we actually are left with x squared minus 2 over 4. Okay, something like that. All right, and there's one more variety here that I wanted to make sure that I talked about with you guys before moving on. And that is if we have a monomial divided by a monomial. Okay, so no factoring required on this one. But there's still plenty to cancel. Okay, so you guys have some rules of exponents that you've done. Actually, you've done ones like this before. Okay, so 36 and 9. 4, right? It leaves a 4 on top. Yep. Now, if you have variables that are multiplied together like this that have the same base but then different exponents, what do you do with those exponents? You're subtracting, right, if you divide? So, 3 minus 6.
So you have to do 1 over x.
Right, it's got to be 1 over x to the third. But I'm going to have you do it like this just for now. 3 minus 6 is negative 3, right? And 4 minus 3 on the y? Just be 1, or just y, yeah. So what you end up with, because it's 4x to the negative third times y, the x ends up going on the bottom, and you've got the 4 and the y on top still, and then your x to the third on the bottom like that. Okay, do you guys remember doing these?
Yeah.
Okay, good. Because we're gonna come across a few of those again today too when we go through the rest of it. So, all right. So, doing some multiplication here then. Let's give it a try. Basically, the rules for multiplying with these is the same as the rules for multiplying any fractions. Top times the top, bottom times the bottom. Okay? So, real quick. What's 2/3 times 5/8? 10. 2 times 5 is 10. 3 times 8 is 24. 10 over 24 reduces to 5/12. Now, before you do the multiplication, though, you could do this a different way and do some cancellation ahead of time. See if you guys remember doing this. Do you see any numbers on top that are factors of numbers on the bottom or vice versa?
Yeah,
The 2 and the 8. So what can you do with the 2 and the 8? Make it a 1, make it a 4, just like you're reducing a regular fraction by itself. And then do your multiplication. It tends to make it a little bit easier then. So 1 times 5, 5. 3 times 4, 12. You're at the answer a little bit faster. Keep this little trick in mind, because when we do some other ones, you can do that too. Okay, when we're multiplying rational expressions together, you're going to want to cancel things before you actually multiply them together. It'll make it a lot easier to do. Okay, so let's try that. Okay, so we got 3x minus 3x squared over x squared plus 4x minus 5 multiplied by x squared plus x minus 20 over 3x. Now, if I took the first approach to this thing, like we did here with the fractions, you could do it, but you'd have to multiply this thing with this thing, and you'd have to multiply this thing with this. Okay? And then when you're done, you got this huge polynomial divided by this pretty big polynomial, and you have to figure out how to factor both of those and start canceling everything out, which is a big pain in the butt. Okay? So we're going to do it like this one. Okay? So each one of these pieces, you're going to check to see, can I factor it right now? And then take a look at what might cancel out from the top and the bottom and that sort of thing. And after that's done, then you can go ahead and multiply it all together and see what you got. Okay? So, take it one at a time. 3x minus 3x squared, is that factorable? What can we take out? 3 and an x. So for that one, I've got 3x, and then left behind would be 1 minus x. Okay, that's the top of the first fraction here. All right, x squared plus 4x minus 5. Can we factor that one out? Two numbers that add to 4 but multiply to negative 5.
Negative 5 and negative 20.
No. 5 and negative 1. That should do it, right? Positive 5, negative 1. So x plus 5, x minus 1. Okay. And then over here, x squared plus x minus 20. Can we come up with two numbers that'll work for that one? Got to add up to 1 but multiply to negative 20. Good. Yep, x plus 5 and x minus 4. And then 3x, thankfully, doesn't factor because it's just 3x. So any cancellations you guys see here before we move any further? 3x will cancel with 3x. What else? X plus 5s will cancel each other. All right. And then we've got this weird little situation with the 1 minus x versus the x minus 1 that look like they might almost cancel, but not exactly. Does anybody know the trick to get those to cancel? Because we can, but you got to do something first. So if you change one of them around, you're changing the value of it, though. So what do you have to do in addition to that? Well, think of it this way. This 1 minus x, what if I were to take a negative 1 out of it? What would it do to both the two signs? It would switch them, right? So that's what you can do. You can take this thing, and I'm just going to rewrite it again here. But if I took a negative 1 out of this, then it would be negative 1 plus x. If you don't believe me, try multiplying that back together and take a look. Negative 1 times negative 1 is positive 1. Negative 1 times x, negative x. So it's the same thing, right? So this is the same as that. And then I still got x minus 1, and then I'm going to still multiply by x minus 4 over there. Okay? Negative 1 plus x and x minus 1. Do you see how those are actually the same thing? It's just this one, the negative 1 came before the x. It's just got added the opposite way. So these will technically cancel each other out. And so all we have left then is this negative 1 times x minus 4. So just take that negative 1, multiply it in, and we've got negative x plus 4. And that would be it, all simplified. Okay? So you can break it down. And this little flipping it around trick, that gets a little bit dicey sometimes if you can't remember that little trick of pulling out the negative 1. But can be simplified down, even using that. So, all right, let's do one more multiply, and then we'll do a divide, and then I think we'll probably be good based on what I've heard from you guys so far. All right, so how about we'll do x plus 2 over x squared minus 5x plus 6, and then we're going to multiply that by x squared plus 3x plus 9. All right. How does this one look different from the last one we just did? What's what? There's no denominator on the second one. Okay? Now, here's the good news. Anytime you have something that's not written like a fraction, you can make it a fraction. How can you do that? Just put a 1 underneath it. Right. So let's just do that before we go any further here, just so it kind of looks the same. Okay, and from there, really the process is the same. Okay, we just got to do a little factoring here to set it up. Okay, so this one, the rest of the way, I'm going to leave you guys to do it on your own real quick. I'm going to freeze this, I'll finish it, and then we're going to compare answers real quick, see if we get the same thing, and then if we're good, we'll move on. Okay, so take a minute, factor those two trinomials, see if you can cancel out everything that you need to cancel, and we'll see what we got. Oh, I think I got the wrong one here. Hold on a second. Let me unfreeze for a minute. Yeah, I copied down the wrong. You can kind of see my solution there a little bit. But anyway, yeah, I wrote down the wrong trinomial here. Hold on a second. So this was supposed to be x squared minus... I think that should work now. Yes, that's the one. Do that. So this over here then is going to be changed as well. All right, yeah. Work with that one instead. The other one was unfactorable, so it really wasn't going to do anything. This one should work out better. All right, do we need more time? Yes? No? No? All right, well, if you're not quite done, don't look up, but here's what I got.
That's not what I got.
Now, did you get this right here?
No. Well, I did something different. But
Oh.
I could have gotten that if I wasn't sure about application.
I'll show you that step too, so you can see. The x squared minus 7x plus 12 should factor to x minus 3 and x minus 4. And the x squared minus 5x plus 6 should factor to x minus 3 and x minus 2. So the x minus 3's will cancel, and then you have x plus 2 and x minus 4 multiplied on top, and then x minus 2 and 1 multiplied on the bottom. So it's just x plus 2 times x minus 4 over x minus 2. Good question. There's some debate about what is more simplified, leaving it factored out like that, or actually multiplying the top back together. And I took a look in your textbook just to kind of see what way they went with it, and they had it multiplied back together. Yeah. There are some, that's the thing, it's not totally consistent. There are some answers in the back that are multiplied back together. There are some where they leave parts of it factored out. So, I don't know. I would rather it just stay factored. I don't care. But I saw some that they multiplied back together, so that's why I did it that way. But if you're looking at an answer in the back of the book and it doesn't match exactly what you have, it might just be a matter of that. Like they multiplied it back together when you didn't or something. I don't know. But in any event, does the process here, though, make sense, guys? So we can move on? Okay. Dividing. The only thing about dividing, and we'll go and do some fraction stuff here really quick first. There's a little rule with dividing, and I believe you guys were taught at some point this thing called leave it, change it, flip it. Does that sound familiar? If not, it's not a big deal. Basically, it's taking the reciprocal and turning it into a multiplication problem. That's what you're doing. So if I had something like 2/3 divided by 1/9, that turns into the problem 2/3 multiplied by 9 over 1. Remember doing these? Okay. And then 2 times 9 is 18. 3 times 1 is 3. And then you can reduce that fraction, which actually comes out to 6 this time. Okay. But again, when you're at the stage right here of turning it into a multiplication problem, you can still do some reducing right in the problem, right? Like make it a 1 and a 3, and then 2 times 3 is 6. 1 times 1 is 1. We're going to do that again. Okay, we're going to take a problem, take the division. First thing we're going to do is just flip it around, make it a multiplication problem, and then it is all the same from there. Factor, 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 factor. Take a look at what cancels out. Multiply what you got left over. Done. Okay, so we'll only do one example because we don't need to beat a dead horse here, but let's just give the division a try here. Let's do this. 7x divided by 2x minus 10. Is he already dead? Oh. Okay. So if you'd prefer to do all your factoring first and then flip it, you could do that, but just don't fall into the trap of canceling things before you flip it, because then it's not technically correct. But what I'm going to do is just rewrite the whole problem with the second fraction flipped before I do anything else, and then I can just rest assured that the rest of it's going to work out just like a regular multiplication problem here. Okay, so same type of idea, right? Take that big fraction, just flip it around. Now the x squared minus 11x plus 30 is on top. X squared minus 6x is on the bottom. All right, I'm going to kind of fly through this the rest of the way here just because we've done these. So now we've got 7x. I'm going to factor the 2x minus 10 into 2 times x minus 5. X squared minus 11x plus 30, that's going to be negative, let's see, x minus 5 and x minus 6. Get the job done there. And then x squared minus 6x, you can take an x out of that, leaving x minus 6. And then we're looking for things that cancel. There's quite a few of them, right? X minus 5, x minus 5, x minus 6, x minus 6, x, x. What's the answer? 7 over 2. Don't forget that, too. Whole thing works out to 7 over 2. Okay, but that's the idea. Okay, so with the time that we have left, I'd like you to revisit that assignment from the day before break. If there's any cleaning, etc., problems you need to work on that you didn't yet, go for it. We got a little bit of time here. We got about 15 minutes left in class. Whatever you don't finish in class, you can work on tonight, and then tomorrow we'll go over the answers for that. Okay?